people in real life, let me say it that way. So really happy to be able to catch eyes during the presentation and present you, let me say, a very innovative solution coming, let me say, from the industrial side, and that will covers both markets as well the industrial side as the IT business, and I will come to that during my presentation. So before moving to the product itself, I just want to share some data with you about the reasons behind the development of such a solution. Because Ralph mentioned it when he presented Panduit, innovation is part of the DNA, let me say, of Panduit. The idea of Jack Kemner was to build a panel conduit around cables to have a proper routing in a control panel. In this case, when our engineers started the development of VeriSafe, they started with the idea of how can we increase safety when it comes to absence of voltage testing. You see on the screen a certain number of some numbers related to safety. You see that in 2019, it's the last data I have in my possession, you see that electrocution was the 6th leading cause of workplace deaths in the US. But trust me, the situation in Europe is really similar. Why do we use US data? Because OSHA puts all the data in one report. In Europe, each country counts it a little bit different, have different terminologies when it comes to deaths and issues. So that's why we use that. But you can trust me based on my experience. Martin mentioned it. It's exactly the same here in Europe. We have also a high level of deaths of people who die due to electrocution. And you see a second point, it's the last line on the slide. We are also speaking about injuries related to running equipment, running machines. I will come to that in a few minutes when I will present you the solution, VeriSafe. But please be aware, these are some of the elements who are behind the development of this solution, VeriSafe, which is here to improve safety when it comes to absence of voltage testing. Just to share a few comments about the standards. When it comes to absence of voltage testing here in Europe, you see the EN 50110 is the main IEC standard who gives the general requirements for absence of voltage testing. You see that they start with disconnect completely the equipment, then secure again against reconnection. So you have to put a padlock or a different system in place to avoid that someone puts the switch again back to working. Then, and I will come to that in a minute, then you have all the processes related to the verification of the absence of voltage. And this is a key element, because today the standard mentioned mainly a portable device. So a device like the one I have here in my hands. And to run properly a test, you have to prove that the tester is working well. Then you have to make a certain number of things to test the absence of voltage inside the control panel or the equipment. And then you have again to prove that the tester is working properly. So all these elements are part of this EN 50110 standard. And again, this standard today mentioned only portable devices. But, and you have some examples here on the screen, so I will not go through all the examples, you can see them. They are coming from real life. It's not just Panduit putting some data on a slide. You see at the bottom of the slide the studies from which these accidents have been taken, or these examples have been taken out. And really, when it comes to making, how can I say, an absence of voltage test with such a device, you have limitations because people are exposed to some risks. You can have a hardware failure. For example, something can go wrong inside the device itself. You have human errors because people don't set up the tester in the right way, do it too quickly, have the mind at home when they do the test. So there are really a lot of reasons a lot of risk having issues doing the test with a portable device. So this is really the background, let me say, that our engineers had in mind when they started the development of a new solution. And the new solution that has been developed, and I will go a little bit more into the details here, is VeriSafe. So what's the main difference between VeriSafe and such a device is that starting from the data I presented for a few minutes, our engineers decided to work on a permanently mounted solution. That means something that is in place in the control panel, in the machine. You don't have to open anything. You can make the test without being exposed to hazards. So this was the idea behind the development of VeriSafe. And let me deepen the solution. You can see the different elements here. So you see that it's a mounted solution. You have one, we name it an indicator model, which is on the front or on the side of the enclosure. You have no electrical voltage here because it's driven by a battery that you have inside the indicator model. And you see, you see inside the control panel, let me say the brain of the system, where all the connections, all the power connections are going to. For your information, I have a test unit in the room just on the other side of the door, and I will be happy to run a live test for you after the presentation. So if you want to see that in real life, I will run that for you. You can see also on the left side of the screen, you have two different possibilities. You have the red lights that you see at the bottom of the screen, which means that you have voltage inside the panel. At the top, you see the green light, which means all is safe, absence of voltage, you can go inside the panel. So it's a little bit like when you're driving your car. You have a green light, you're safe, you can run. If you have the red light, please take care, there is still voltage inside the control panel. So that's the, let me say, the idea behind VeriSafe and the way the solution has been built. Sorry. So let me go to the, how can I say, the test method itself, because I've mentioned the standard is speaking out a certain process that you have to follow in order to make an absence of voltage test. You see that if you look to both, at the top you have the one with the portable tester, at the bottom the one with VeriSafe. You see that they are relatively similar. However, and that's why I have all these accessories with me. To run the first one with the portable tester, the first thing you have to do, you have to wear a helmet. You have to wear goggles. You have to wear gloves. You have to select your tester. In some cases, you have to have an isolation mat or specific shoes to really avoid any risk to be exposed to hazards. Because to run the test at the top, you have to open the panel. You see it on the picture of the guy on the right side. You have to open, so you are exposed to potential electrical risks. So that's the reason why you have to wear all this equipment. So I did it here in 1.5 minutes, but think about the real life in front of the control panel. It takes some time to put all that stuff on. And imagine, in some cases, you don't have it with you. So you have to go back to your office, take these elements, bring it, wear it, and run the test. So based on our experience, and you see it also on the screen, we see 10 to 20 minutes to really do an absence of voltage test with the standard methodology, if I can name it that way. When it comes to VeriSafe, and that's also the reason of the title of my presentation, one button for safety. When you have VeriSafe, and again, real life demo after the presentation, you just push a button, and in less than 10 seconds, VeriSafe will do the job for you. So no exposure to hazards. You see at the picture, and I got the question from a customer because you see the guy is wearing a helmet. You don't need to wear specific equipment to run a VeriSafe test. It's not the best picture we selected there. You can do it without helmet, without gloves, just push the button, and VeriSafe will run the full process. Again, VeriSafe will test itself. VeriSafe will test for voltage, absence, or presence. And in addition, to follow the rules of the standard, he will also verify that the model is connected in the right way to the power cables to avoid any connection issues. So we are really on a reliable solution. When the green light pop up, you can be 100% sure that there is no remaining fault in the control panel. And again, less than 10 seconds. So we speak about safety, and the title was really about safety. But think also about efficiency, because in today's world, efficiency is a key element also, and time is money. We know it all. So this is also one of the reasons why people see a lot of interest in a solution like VeriSafe. So, without going too much into the details, but just to share what VeriSafe is doing during the test, what really happens during the test. Because in less than 10 seconds, you can think, is the test really a great one? You see here the different steps. So we confirm, first of all, that power is available to perform the test. So that means, do we have enough power in the battery to run the test? We check also that all the components inside the model are working well, and that the threshold of these chips and elements are at the right level. We check on a known voltage source to be sure that we are connected to the power connectors. We verify the connectivity, I've mentioned it, and then we verify that the remaining tension is below 3 volt. Why 3 volt? Because the UL standard specifies 3 volt as the lowest, power before confirming the absence of voltage. So it's based on the UL standard, and 3 volt is the lowest tension. If you go below, the system will move from the red light, or from no light to green light. So, what I've presented earlier is related, just go back. It's named VeriSafe 2.0, but what I presented for the moment is really common between VeriSafe 1.0, so the first version, and VeriSafe 2.0. VeriSafe, the first version of VeriSafe was launched in the market in 2018. And we had a lot of success with this solution. UN changed their standard, NFPA changed their standard to integrate a solution like VeriSafe into their requirements. And when we launched the first version in 2018, we had very good reaction from the market, but also some requests. Can you improve that? Can you improve that? Can we have that additional feature? And Panduit is also, I mentioned, innovation is part of our DNA, but we are also really listening to the market. to see what's needed or how we can improve the solution we bring into the market. So we don't say, okay, we have launched a product, let's take it as it is. We are really listening to the market. And we had a certain number of feedback coming from the customers, from the people installing or using VeriSafe. And this is the reason why our engineering team started or continued the journey on developing VeriSafe 2.0. So VeriSafe, we name it 2.0, is the new version of VeriSafe. I would say today is the official pre-launch of VeriSafe because we wanted to share the information in advance with you from the press. So today it's the first day. It's really the start of the pre-launch activities. Product is planned to be available in July. 1st of July if all went well, but let's say July as a time frame. And VeriSafe 2.0 has some additional features to the ones of the first version of VeriSafe. First of all, is a battery-free option. Because I've mentioned VeriSafe, this one works with a battery, but in some cases, some customers mentioned we don't want battery. We prefer a different solution. So our engineering team took that in consideration. More to come on that on the next slide. The second element, VeriSafe 1.0 is rated up to 600 volt applications. This was in some cases a limitation because in Europe we have also a certain number of systems running with 690 volts or even more. So this is also a new feature of VeriSafe 2.0 who goes up to 1000 volt applications. An additional requirement was to be able to initiate the tests from different locations. Because VeriSafe 1.0 you had to put it on the control panel. But if you look to an industrial site, in some cases you have the control panel on one side of the machine and you have a door that you have to open some 10, 20, 30 meters away from the control panel. So to avoid that the people have to go to the control panel, push the button, we have now the ability to do it from two different locations. And an additional feature is related to the network connectivity, because this was also a request coming from our customers. We would like to be able to monitor and record the data and what happens with VeriSafe. So let me speak quickly about the indicator model. Here you see the one working with a battery. So just also for information, it's an industrial battery with a lifetime of 5 years. It's not the standard AAA battery that you buy in your local shop for your home stuff. It's really an industrial battery with a long lifetime. But, and you can see it on the picture on your left, you have also the battery-free indicator, which is also a nice option in case you want to reduce the space occupied by the indicator model in front of the control panel or on the side. And you see also here on the right side of the screen that we have now a three-phase version of the faceplate and a single-phase DC version of the faceplate. So all these elements are improvements to the first version. The isolation module is the brain of the system which is installed inside the panel. It's also what prevents hazards to go to the door. So it's really here that all the energy are coming into the system and where, how can I say, all the intelligence is sitting. Yeah, let me say it that way. You see that you can easily install it. So you can install it on green application.